honest, I think most people find it hard to think in abstract terms, and that includes software engineers, even though it is our job to think in abstract terms.
Welcome to the LabVIEW Experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes. So I am here today with Clare Sudbery, who I met. Actually, I'm not entirely sure how we first met. Maybe through Emily and the Samman Coaching thing. And yeah. I definitely got exposed to you from listening to your podcast, Making Tech Better. I think that was the first time I'd heard your name.
Okay. Well, we definitely did meet via the Samman Technical Coaching Society. So I think that was probably the first time that I met you, was via the Samman Technical Coaching Society and Emily Bache. Yeah.
Yeah. So maybe that's a good place to start our conversation. For those who don't know, what is Samman Coaching and what is this society?
Well, yeah. That's a great question. So the Samman Technical Coaching Society was founded by Emily Bache, and Emily Bache is a technical coach based in Sweden. And that's where the name comes from. So the word Samman is Swedish for together. And that's a really key word that describes Emily's approach to technical coaching. It's probably worth me even starting by describing what technical coaching is, because not everybody knows. So the idea of technical coaching is that a coach comes in and works with software engineers and software teams to help them to improve their software development practices. Emily and I and everyone associated with the Samman Society is particularly interested in the set of practices that are broadly described sometimes as extreme programming. So they are practices like test-driven development, pair programming, continuous integration, continuous refactoring. And the way that Emily works, the Samman Technical Coaching method, is to work directly with a team on their own code base. And the Samman Technical Coaching Society is Emily's mission to increase the number of technical coaches in the world. So the Technical Coaching Society is to help technical coaches get going, to help give them resources, everything they need in order to be technical coaches. Because Emily's view is that software engineers typically actually don't get a lot of training on the job. They particularly don't get hands-on training in their own code bases. So techniques like test-driven development and pair programming are not easily learned by programmers. They don't tend to be taught in universities. And even if they are, they're best learned on the job with a real life code base. And that's not very often done. So Emily's mission is to increase the number of technical coaches in the world, increase the amount of technical coaching that's being done, and ultimately to increase the skills of software engineers.
So to that end, correct me if I'm wrong, but I think her goal is not just to increase the number of external consulting technical coaches, but also to build up internal coaches as well.
Yeah, exactly. So it's not even exactly a professional body. So it's not like it's there to support all of the freelance technical coaches. It's just to increase the number of people doing technical coaching, whether they be freelance or in-house. Because Emily's mission is to increase access to software engineers of technical coaches. So one way of doing that is for companies to hire external expertise in the form of freelance coaches, but the other way is for companies to train up their own technical coaches. And actually, that's one of the things that Emily offers, is in-house training for people within a company to learn how to be technical coaches and how to support the rest of the software engineers. And that doesn't have to be a full-time job. That could be another string to the bow of, for instance, a senior engineer or a tech lead.
Yeah, I feel like senior engineers and tech leads often find themselves in that coaching, mentoring position, but they don't really have a lot of training in how to do that.
Yeah, exactly. And it's really common. There's actually at least two models. One thing that can happen is that somebody who's in a leadership role or a senior role has an interest in mentoring, and actually has an aptitude for it, but doesn't get much support from the company because there aren't any structures in place for them to formally do that. So they just have to sort of grab what opportunities they can. But the other side of it is when you have people in leadership positions who are being asked to mentor more junior engineers, but they don't feel like they have the skills or the resources to do that. They don't have experience of teaching, they don't have experience of mentoring, they don't have experience of coaching, and they need a little bit of support to get really good at mentoring and coaching.
Yeah, so the Samman Society then offers classes on how to teach these things. Right.
Yes, exactly. Yeah. So there are classes to help people to deliver resources, deliver teaching resources to their fellow engineers. And there are also classes in how to do things like facilitating ensemble work, which some people call mob programming. So and the Samman technical coaching method itself has these two prongs. Part of it is about delivering what we call learning hours. And that's where you have a structured hour of learning where you're addressing something very specific and you're helping engineers to learn particular skills. And then there's the ensemble piece, which again, some people call mob programming. And that's where you get the whole team together, looking at their own code base and working together as an ensemble and deliberately trying to increase their skills in things like test-driven development and refactoring, but doing that on their own code basis so that it's meaningful, it's on code that they actually know and use on a regular basis. So with the training that's offered to technical coaches, the training covers both delivering learning hours and facilitating ensemble work. And it's not just about facilitating that work, it's about thinking about how you can direct a group of engineers to work with their own code base and work together effectively in a highly collaborative way, but also direct them to increase their proficiency in skills like test-driven development and refactoring.
Great. So I want to ask a few questions. So recently I did a workshop, and it was a 2-day workshop on unit testing. And so I have a few questions around that and some feedback that I got. And one of the feedbacks that I got, so these were people from various different companies that all came together, and we sat down and we did some Zoom sessions. And actually, I will say, first of all, that going to the Samman training courses definitely influenced the course a lot. I taught it before, and it was a lot of slides and a lot of theory, and now it's a lot more practical, like doing various katas and things like that and examples. But one of the feedback that I got was that for the audience that I serve, they're mostly LabVIEW developers, and so they're often working directly with pieces of hardware, like sending out serial commands and getting data back and things like that. And one of the complaints that I got was that a lot of the exercises did not reflect that. A lot of them were on other things that are more computer science-y, I guess would be the term that they might use. And I was wondering, A, like, do they need to be that relevant to exactly what they're doing, A, and B, if you're doing the Samman coaching, does it kind of make that irrelevant in that you're learning the technique on something that's maybe not relevant to your code base, but then you go apply it in your code base? Is that like a way to overcome that?
Kind of. So was this a course that was delivered by you?
Yep.
Yeah. So there's a few things in there. The principles of unit testing and test-driven development are effectively abstract principles, and they can be applied to any context. But people often find it difficult, depending on where they are and depending on how used they are to thinking about things in abstract terms. People often do find it difficult to take an exercise that they've done in one context and then apply it in a different context. And sometimes there are practical issues in the way. I know LabVIEW is actually quite an unusual technology and does work quite differently to other ones. So it's like people will think, well, I know how to do it in this language or this framework, but I don't know how to translate that into LabVIEW. So sometimes it's a practical problem. You know, I just don't know how to do this in my context. And sometimes it's an abstract problem. It's like, oh, well, I can imagine doing it in that context, but I'm having difficulty translating that into the new context. So all of that is a reason for trying to create exercises in your own context if you can. And that does mean that when you're working in an unusual context, there's a little bit more work for you to do. Because, for instance, if you're working in JavaScript or C# or Java, there are already a lot of resources out there that you can reuse. When you're working in something like LabVIEW, I think that's probably a little bit harder. So you probably have to do a bit of extra work yourself to create exercises in your own context. But it is possible to translate from other contexts. It's just that you probably, as the facilitator, need to know what the connection points are. So let's say you deliver an exercise that is in Java, you have to know where the points of contact are between that and your own technology and your own framework. And you need to be able to say, right, see, here I'm using this particular part of the Java language, but if we were doing this, we would do this, you know, in whatever way is relevant. I confess, I know very little about LabVIEW, so I'm having to talk in abstract terms here. But yeah, it does often help people if the exercises they're doing are as close as possible to their own context. And if they aren't, then you sometimes have to help them make the connections to say, if this were in your context, then you would do it like this. But there are definitely, you know, some really, really fundamental principles to, for instance, test-driven development. So the idea that you write the test first, you see the test fail, you make it pass, and then you refactor. That can be done in pretty much any context. So that can be done in hardware contexts. It can be done in all languages. But the way that you write a test is going to change. The way that you run a test is going to change. But that fundamental concept of writing something very small that's testing something very small and seeing it fail and then making it pass and then refactoring it. I've done that in so many different contexts now that I know that it works in all contexts. But sometimes that takes a bit of imagination, particularly if people aren't used to doing it, because in fact, it's sometimes surprising to those of us who are immersed in the world of test-driven development how few people do it and how few people know it and how much of a culture shock it is for people. So if you're trying to introduce one culture shock to them, then, and also they need to embrace another culture shock because you're showing it to them in a framework that isn't familiar to them, then that's two cognitive leaps they're having to make. And that's a lot. So that might mean that, for instance, you have to move a bit more slowly because as well as giving them this new concept, you've also got to help them to translate it into their own context. Does that make sense?
Yeah, no, what you're saying makes a lot of sense. I think in my case, I had translated a lot of the katas from Java or whatever, Python into LabVIEW. So like that part wasn't the problem. The problem was more the domain. So a lot the domain, for example, like the grocery store kata, like there's the grocery store receipt kata.
Yeah.
We're not creating grocery store receipts in LabVIEW,
Yeah.
right? Or any of the
Yeah.
things that deal with like web stuff where you're rendering web pages and stuff. Like LabVIEW is not used for that. So the domain feels off.
Yeah.
Even if the actions you would take, you run the test the same way, you write the test the same way, but getting people to make that leap. And I don't know, I don't know if it's like some people maybe are better versed or more experienced in thinking in abstractions as opposed to other people maybe need more concrete
I
example.
mean, to be honest, I think most people find it hard to think in abstract terms, and that includes software engineers, even though it is our job to think in abstract terms. We will always be thinking in abstract terms in the context of something concrete. So whether it's the domain or the fact that we're working with hardware, we're thinking in abstract terms about something concrete, about something that is going to turn into a tool that somebody's going to use, that is going to feel concrete. And so if you're asking people to think in abstract terms about something that's not meaningful to them, so like you said, another domain, then it's the same problem that I was describing before. They're learning a new skill, which is one cognitive leap, and they're having to translate from one domain to their own. And one of the things that you have to accept and acknowledge is that when you're asking people to think about things in a new way, there's probably going to be some resistance. There's going to be some, well, I don't do it like that, and I'm not used to doing it like that. So whether consciously or not, I might be looking for reasons to dismiss it. Well, this doesn't apply to me because my context is different, and why I can't do these things where I am because things are different for me. So having a different domain will increase that sense of, well, this is just different. This doesn't apply to me because I'm not making grocery carts. So, and so again, that means that you either have to do a bit of extra work explaining how to translate it, explaining why this work will work in your domain as well as this other domain, or you have to do the extra work of creating new exercises that are in their domain. And that's, I say that, but I know that's not easy. Coming up with examples is incredibly difficult. But one of the things that I find really helpful, and I know that Emily does this too, is all the time when we're working, we're looking for examples. So in your day-to-day work, in the code bases that you're working with, you're looking for examples and thinking, okay, so here's an example where tests would help, or here's an example where more granular tests would help, or here's an example where it would help if we made the test fail before we made it pass. So you're always looking for those examples and then making a note of them when you see them and thinking, okay, how can I turn this into something that could be the core of a workshop? And it might be, because turning something into a workshop exercise can be a lot of work. So it might be that rather than doing that, what you can do is you can use a workshop exercise that's already been developed by somebody else, but keep an eye out for examples in your own code base on your own domain that could have similar principles applied. And when you run the workshop, you say, and by the way, here's an example of a context that's relevant to you, that's in your domain. We're not going to do the exercise in that context because that would have been too much work for me to do. But here's an example that works in your domain that you're used to. And then so you're helping them. So you're looking for the connections, which means when you see them, you can present them to people and help them to make the connections. Does that make sense?
Yeah, no, actually, I'm making some connections right now. So, like the shopping cart receipt kata, where you're like putting stuff in a cart and generating a receipt. The receipt is kind of like a report. So, if you were making a test, maybe you would have several different tests that run and they all generate data, and then it all goes into a report at the end. And that could be, and maybe the printer, so the report might be like, something that would JSON or something would go in a database and you could have a printer that prints it out really nice or something like that.
Yeah, exactly.
Okay.
Yeah.
Yeah, that's making sense. Yeah, I just look at that. Even just translating katas from Python to LabVIEW is difficult. And
Yeah.
and sometimes
Yeah.
too, part of the difficulty is like the syntax is different in Python. I'm wondering like if I change the syntax, how much am I actually changing the actual kata? And like, do I translate it exactly literally, or do I do it how I would do it in LabVIEW? But then like
But
it's one of those things where I do it in a good way in LabVIEW, and I want it like, especially the refactoring katas, you want to do it in a not so good way so that people have a chance to experience what bad code looks like. Although most
yeah,
people have experience with that, but
that's one of the challenges of coming up with good examples, because you have to be able to demonstrate bad code in order to be able to turn it into good code, and that's one of the hard things to do. But if you want people to go and use these techniques in the context of LabVIEW, then they're going to have to be able to do that anyway. So I think it probably is worth the extra effort of you being able to convert things into the LabVIEW context, because that helps you to understand the challenges that they're going to face anyway. And I think that it's a really useful exercise, trying to translate something from, for instance, Python into LabVIEW, because it gives you an idea of where the connections are. Or, if I had limitless time, which of course I don't, none of us do, then I would spend a lot of time converting exercises from one language to another. And I do it whenever I can. And I always enjoy it when I do, because doing that gives me so much insight into both languages. It gives me insight into the connections between them, but also the differences. It's like, oh, okay, this is the same in this sense, but it's different in this sense. And then it helps you to understand what those differences are when you try to convert something from one context to another. But it also makes you recognize what the points of contact are.
Yeah, it's interesting. You see a lot of different patterns. So some of the patterns that are used in Python are like, oh yeah, I recognize that from the Gang of Four book, but nobody really does that way in LabVIEW just because it doesn't fit the language very well.
Yeah, yeah,
There's a little bit of
yeah.
that.
Yeah, and one of the challenges as well, one of the things that I've struggled with in the past is if you come from one context. So, for instance, historically, I've had more experience doing C# and .NET than other things. And there have been times when I've translated an exercise from, for instance, C# to, for instance, Ruby. And I've tried to make Ruby behave like C#. And you can do that. It's possible. But it's pointless, because the problem is that you then show this to Ruby developers and they're like, well, that's not how we write Ruby. That's not idiomatic, so it's not meaningful to us. So you have to learn the idioms of the target language, which I mean, you're in the lucky position, actually, if you're translating something into your own domain and your own technology, then you absolutely know what's idiomatic for your own technology, so you can do that. But the problem I've had is when I've been translating something from my own domain into somebody else's technology while not being used to working in that technology and not really knowing what's idiomatic, and so just trying to make it look like what I'm used to, which is then problematic.
Those exercises are actually quite useful because oftentimes we get people who are C programmers who start programming LabVIEW, and C is very procedural, and you can instantly tell that they're C programmers just from the way that they structure the code. And
Yeah.
so sometimes having examples of that is actually good because like that's something that people encounter often.
Yeah.
And so knowing how to deal with that and like the specific refactoring issues that come up with that, and like partially too, I think there's an empathy component there of when you see that, you recognize what's going on. Like you instantly know, okay, this guy's not an idiot. He's just a C plus or C programmer who's
Yeah.
trying to program LabVIEW like it's C.
Yeah.
And so then
Yeah.
yeah.
And one of the things that can be tricky, so for instance, I have built a couple of iOS apps, and the thing that I found really frustrating about it was that I wanted it to be testable. Like, it's really, really important to me that things are testable. And also, what that means is, particularly if I'm working with something with a front end, is I want to be able to separate the domain logic, and I want that to be testable independently of whatever's happening on the front end. So if I've got back end logic that that needs a complex series of things need to be true, and there's a bunch of edge cases, then I want to separate that from what's happening in the UI, because I want to just to be able to test that the logic is correct. And it's true of quite a lot of the kind of app-based frameworks, that the default that you're given out of the box assumes that you're basically going to test your logic in your front-end tests. And I'm like, no, no, really don't want to do that. So therefore, I'm effectively changing the way that framework works. I'm not doing it idiomatically to how, for instance, various Swift frameworks are built, because I want it to be testable. But in order to do that, I have to change the way that iOS code is typically written. And it's very difficult to know, am I doing this because I'm making it more testable, or am I doing this just because I'm used to working in C# and I'm making everything work in the way that I'm used to? So in trying to know when it's okay to break the idiom because you have a particular goal in mind, that you're going to have to break the idiom in order to meet your goals, that can be really tricky. But you just have to be able to justify what you're doing and say, look, I've changed the way this works because I need to make this testable. My tests are going to be much quicker and more reliable as a result of what I've just done. And I know this isn't idiomatic, but it's going to make the code more robust.
I was gonna say
And that's tricky.
sometimes the idiomatic way is not necessarily the best way in the sense that in LabVIEW we have these messaging frameworks that like basically let you spin up parallel processes and send messages between them. But people often they put their business logic or whatever you want to call it directly into the messaging code, and it gets kind of
Mhm.
all tangled. And yeah,
Yeah.
I very much preach against that. I'm like, build your business logic as its own separate entity, test it by
Mhm.
itself, and then wrap it in the messaging code to do what you need to do.
Yes.
Otherwise,
Yes, that's a really good example. Yes.
yeah,
Yeah.
and I don't think enough.
But speaking of examples, sorry, just to rewind slightly, I think that is absolutely key to teaching, always. No matter how good people are at abstract thinking, they will always find it easier to learn a new thing if you can give them a concrete example. So that's why it's so important, if you can, to find examples in the target domain and the target language, because examples make things so much easier for people to understand. Even if they're good abstract thinkers, an example is always going to make it easier to understand what you're going on about.
No, yeah, that's a great point. So going back to teaching, I have a question. So I taught this unit testing workshop, and one of the people who attended was more advanced and he was really into TDD. And and I kind of approached it as I'm just teaching unit testing. I'm not teaching TDD.
Mm-hmm.
And just like, here's some existing code. We're going to write some tests around it and just get practice doing that. And he kind of rebelled against that because like, oh, this feels weird. And I have to admit for myself, it did feel weird as well, writing tests for already existing code. But I feel like, and I've heard this from other technical coaches, so I'm kind of curious to get your opinion, that TDD really requires knowing how to write tests and knowing how to refactor in order to actually be good at it. And so I feel like if you try to teach it without that, they get stuck in the circle. They get to the point where they're ready to test, like, how do I write a test? And then they get to the point where they're supposed to refactor, and like, I don't know any refactorings, and what am I supposed to do here? Does that ring a bell or?
There are lots of different ways of approaching things. So I can see the value in teaching testing as a separate skill. But I think there's two things in there actually. So one of the things was you said if you're used to TDD, then it can feel weird to be adding tests to existing code. But actually, whether you're used to working in a TDD way or not, you are going to be faced with legacy code that has no tests. That is a very, very important skill, to be able to add tests to code that is not tested, because you're not always going to be in control of the code that you're working with. It's not always going to have been written by you. So even if you are a person who always does test-driven development, you're going to be incredibly lucky if you never have to work with code that wasn't originally developed by you. And if you are working with that code, chances are it's not going to have tests, and so the ability to retroactively add tests to existing code is a very, very important skill, and it's a really good way of practicing the ability to write tests. And actually, it's an important refactoring skill. And a lot of people I know say that they find it easier to teach refactoring first and then teach TDD, which is exactly what you were just suggesting. So, and in order to be able to refactor, you have to be able to add tests. Because in my view, and I think you agree with me, I never want to refactor code that isn't tested. But I quite often find myself having to refactor code that isn't tested. So the first thing I have to do is add tests before I can refactor. And those two skills, adding tests to existing code and refactoring it, as you quite rightly said, are two very useful skills for test-driven development. It is possible to start from scratch with test-driven development, but you have to move really, really slowly. You have to, and this can be the problem that all teachers can have, because typically if you're teaching something, you're in a position of knowing a lot more than the people that you're teaching. And it's very, very difficult to put yourself into their heads. It's very easy to forget what it was like when you didn't know the things that you do know. And it's also very easy to think, well, I know this stuff and it seems simple to me, so I'll just be able to teach it to them really quickly. But you forget it takes time to learn new things. So if you're teaching TDD from scratch, you can do it, but you have to move really slowly. So you have to start with a very, very simple kata, and you have to do it several times. And you have to be patient and know that people, paradoxically, people will move slowly because they'll try to move too fast. So people who are not used to TDD will want to test all the things all at once. So the idea that you just make a tiny, tiny step forward and write a test for it and see the test pass, people who aren't used to it will get impatient. They'll be like, oh, but I don't need to test this tiny bit of it. I just want to test the whole thing because I can already see what I think the whole thing should do. So you have to take people on that journey. And what some people do is they say, I'm not going to start with TDD. I am going to start with unit tests, or I'm going to start with refactoring. So that is entirely valid, because if you start with TDD, then you're right. You're having to teach several skills all at once.
Yeah, that's one thing I like. I don't know if you mentioned, Emily has a bunch of lessons, those pre-recorded lessons. What does she call those? Guided learning
The
hours?
guided learning hours. Yeah.
They're pretty good for that because most of those are really targeted. Sometimes it's surprising how small of a thing you can work on, but it's kind of like that. If you've ever done like martial arts or something where you do the same move over and over again, but you just kind of tweak little things, and it's very much that type of philosophy.
Yes. So the guided learning hours tend to cover very small topics. So there certainly is not, and should not be, a guided learning hour that teaches TDD. There are lots and lots of guided learning hours that teach aspects of TDD or teach things that are related to TDD, but you can't just learn TDD in an hour. So what she tends to do is kind of build up just really small aspects, like let's look at this very specific type of refactoring, or this very specific refactoring technique, or let's look at this very specific thing about how to write good unit tests, rather than let's just do TDD in an hour.
So that brings up a question that I have for you. How do you prep the people you're coaching for the fact that it's kind of small incremental improvements that eventually, like, right? It's like, how do things change gradually and then suddenly, right? Like you pull up all these little things, it's just moving, that all of a sudden, oh, I get it. Now they all click and make sense. When you're selling it to people, how do you get them in the right mindset so they're not like, oh, well, we did a month's worth of lessons and we didn't see any immediate improvement, so therefore we're done with this training, it's not useful.
The interesting thing is that the participants themselves, in my experience, even if they might have that mindset before they enter the coaching, they don't tend to have it during and after. It's more likely to be the people who are paying for it and booking it who worry about that kind of thing. Because what you have to remember as well is that the technical coaching that we're doing, where we're working with software engineers, these people already have a job. They already are software engineers. So I have also run training schemes for people who are brand new to the industry. But the technical coaching that we're talking about tends to be with people who are already professional software engineers. And so it's not like they're starting from ground zero. They do already have skills. But a really common frustration of software engineers is that they are constantly rushing to meet deadlines, and they never get to just stop and practice their craft. And they never just get to stop and think about a particular technique in detail and have a go at getting better at it. And they love that. They really value the fact that, at whatever cadence it is, but typically it's once a week, they get to slow down and think about a particular technique. And it will be in the context of their code base. But what we don't do is literally work on the tickets that they're trying to deliver straight away. So what we do is we'll take an area of the code base that they have concerns about. The typical thing, the most likely thing, is that there'll be an area of the code base they've been wanting to refactor for ages, and they've kept putting it off, but it's a bugbear. It's being annoying everybody, this particular bit of the code base. And we say, we're going to take it offline and we're going to deliberately do it slowly over the course of weeks, but every week we're going to come back to it. And they love it. Because who doesn't have a bit of the code base that they've been wanting to refactor forever, but they've never got round to it? And they're not sure how. So being able to slow down and spend time on really focusing on quality and focusing on useful techniques, and being able to practice those techniques in a context that's meaningful to them, in something real, is really rewarding. And what you'll see is that they, a lot of the time, there'll be a really uneven spread of knowledge and experience across the team, because that's always the case with all teams. So some of the people in there might be relearning things that they've learned before, but it'd be quite common for them to say, oh, yeah, I mean, I love TDD and I've been doing it in my spare time and I've done it at workshops, but I've been desperate to do it with this team and we never seem to quite manage it. And we try and do it, but it keeps falling by the wayside. So I'm really enjoying getting to brush up on those skills. That'll be some people. Some people will be like, well, I've heard of it and I've never really been sure what it is. So I'm loving the fact that I'm getting to see it in practice in the context of my code base. And so what's happening is they're either reinforcing existing stuff or they're learning new stuff. And they understand the benefit of learning new things and seeing them in practice in a real context. They don't expect that they're just going to suddenly magically overnight become different people. What they do is they see the benefit of being able to just focus on their craft for a little while. And the benefit is it can be more subtle than just, oh my God, we're suddenly 10 times faster than we used to be. It can be just, oh, hasn't it been wonderful all spending time together once a week? Hasn't it been wonderful reconnecting with each other? Hasn't it been wonderful learning how to collaborate more strongly with each other? Hasn't it been wonderful getting to know each other a little bit better? But also, hasn't it been wonderful learning a bit more about these techniques or being reminded about these techniques and being given concrete examples of how we can use them in our own code base? And typically what you find is that they start saying things like, we're pairing more often, or we're now using test-driven development more rigorously, or we started writing more unit tests, or it's different for every context. But they do see the difference and they do feel the difference in the practices that they're using, but also in just being given a bit of space to think.
Yeah, no, I could see that. I like the approach of picking that hard to tackle area and refactoring, because I feel like once they've refactored that, the skills that they gain, then all the other refactorings then by definition are easier. So that should just naturally be happening on its own.
Yes, although one of the things that I've learned is it can be very tempting to pick the nastiest bit of code, the one that is the hardest to refactor. And actually, that's not the best starting point. Because you're teaching several different things at once, and you're also helping people to collaborate, and you're helping people to come together. If you pick the nastiest bit of their code base, you're going to struggle to make as much progress as you want, because there's too many things going on all at once. So actually, my top tip is to pick something easy. So pick something that they've been wanting to refactor for a while, but actually that they don't think is a particularly difficult task, something they think is quite easy, they just haven't got around to it. Start with something simple, like in everything, always start small. Because if you start with something incredibly big and difficult, you might not actually get to the end of it. And then that's going to be frustrating. So start with something small and simple and give them that win, that feeling that they've accomplished something before you move on to something meatier.
Okay, cool. So I mentioned earlier that one of the ways that I knew you was from a podcast called Making Tech Better. You want to talk about that a little bit?
Yeah, so I mean, actually, the podcast is now over, but the episodes still exist. There are 27 episodes, and I absolutely do encourage people to listen to it because they're all still very relevant. We made it over the course of a year, so we published one episode every fortnight for a year. And the reason it's 27 and not 24 is because we started with 4 episodes that we started with, and there were gaps. But anyway, that's just me getting obsessed with maths. But there are 27 episodes, and what I did, so I hosted nearly all of them. I think 3 of them were hosted by my colleague Kyle. And we, every episode, we interviewed an industry expert. So Emily was actually one of them. In fact, that is how Emily and I got to know each other better, was because I interviewed her for the podcast. And you won't be surprised to hear that that episode was about refactoring. And I also interviewed G. Paul Hill about test-driven development. But I also interviewed people about a bunch of other stuff. So servant leadership was one of the episodes, and the product mindset was another episode, and working with legacy code was another one. Toxic technology was one episode. That was because I was working in the public sector. I was interviewing a long-standing public sector technologist who wanted to talk in the UK, who wanted to talk about the way that tech is funded in the public sector in the UK, and the way that public sector tech projects are funded and the problems that that causes. So there was a whole, they were, I mean, I think obviously that they were all really interesting, but it was also a fantastic experience for me. So I also interviewed Matthew Skelton about team topologies. So the book that he wrote with Manuel Pay, which has become extremely popular. And for me, it meant that I got to meet all these really interesting people and ask them about their areas of expertise. And I got to learn a lot in the process, but also the aim was always to make these topics accessible to as big an audience as possible. So I would always be deliberately making sure that all terms were defined, and that we weren't talking in jargon, and that what I wanted was to be able to introduce these topics maybe to an audience who hadn't come across them before, or, you know, and not necessarily to a software engineering or direct, you know, not necessarily to software engineers. So to other people who work in tech as well as software engineers. And I find that, just personally, I find that really satisfying, making topics accessible to wider audiences and explaining things in terms that will make sense to people. So I found the whole thing an incredibly rewarding experience, and I've had a lot of feedback that those episodes are, you know, are valuable and enjoyable for people to listen to. So I'm proud that it's out there and still available for people to listen to.
Yeah, I remember listening to many of those and quite enjoying it. I do think that is an important point, though. There are a lot of people in our orbit in the tech space that are not necessarily programmers or software developers, right? There's project managers, there's marketing people, there's, you know, all developer relations people. There's all kinds of other people who are not necessarily coding every day.
Yeah, but they, you know, they hear people throwing these terms around, and they don't always know what people are talking about. So it's useful to them to have these things kind of explained in terms that will make sense to them. But also recognizing that, you know, the people who aren't software engineers, so the business analysts, like you say, the project managers, the product specialists, the UX specialists, they have a lot of technical expertise. You know, just because they're not software engineers doesn't mean that they don't have a lot of technical expertise.
Yeah, no, definitely. So speaking of thinking of other people, one of the other ways that I know you is through empathy in tech. And Andrea Goulet, I think you did a presentation for them on compassionate refactoring.
Yes, so that is a presentation that I've delivered now in lots of different contexts, and it's been very popular. So I've delivered it at keynotes, at events, I've delivered it at private events, I delivered it, like you said, for empathy in tech. And the basic concept, and it's not the only talk that I have that kind of covers this idea, but the idea is that when we're building software, we are human beings building software. We are not machines. We're working with machines, but we are not machines. And in order to be able to build software, it's extremely difficult these days to do that as a solo exercise. You're nearly always going to have to collaborate with other people. And in order to collaborate with other people, you have to be able to communicate with other people, and you have to be able to get on with other people. And a really important part of that is being able to think about things from their point of view. And I think that, unfortunately, it's a natural human impulse to organize ourselves into small groups and then blame everybody else. problems that we have. And with the most obvious context for that within organizations is that teams will form tight units and then blame each other. So they're like, oh, well, that's their fault that this is going badly. But we can also do that to each other. We can kind of we can find ourselves competing with each other or blaming each other for things that are going wrong in our software. And the idea of compassionate refactoring is that there are reasons why people don't refactor. So pretty much, and at the start of that talk, I asked the audience various questions that are designed to tease out the fact that most software engineers do not refactor as much as they want to. And it's not because they're bad people. It's not because they're lazy software engineers. They want to do it more, but there are lots of things that get in the way. And the most obvious one is deadlines, that everybody's in a rush and people are being impatient and trying to get us to move faster. And it's really easy to put refactoring to one side and also to put tests to one side in order to move as fast as possible to meet a deadline. And even though we all pretty much know that when we do that, it slows us down eventually because we end up with so much tech debt and we end up with bugs, it's still really difficult to resist. And really what I like to talk about is how we can help each other to slow down by showing empathy to each other. And also how we can be aware of how sometimes our behavior can make each other feel worse. So another talk that I often do is called Let's Stop Making Each Other Feel Stupid. And that's something I'm particularly aware because I do a lot of teaching, is how much insecurity there is in this industry from people feeling stupid. And here I am talking about the technical professionals, the software engineers, the people who are supposed to have all of the technical expertise, rarely feel completely proficient. They nearly always feel like they're not as capable as they're supposed to be. You can call that imposter syndrome. It comes in varying degrees, but we nearly all have insecurities where we worry that we don't know as much as we're supposed to. But the way that we behave towards each other can actually make that worse. So we can behave in ways that make it seem as though everybody's supposed to know more than they do, so that we just help those insecurities to get deeper in each other by the way we behave to one another. So one of the things I talk about a lot is how we can nurture and support each other. And the most obvious example, and this is something that comes up in almost every talk I do, is encouraging people to ask simple questions and creating environments where questions are okay. And there's no such thing as a stupid question, because if you have a question, that means you need to know the answer. So it's not stupid. Like, if you need to know the answer, you need to know the answer. So how could that possibly be stupid? So it's not. So one of the things that I talk about is how to encourage people to ask questions and how to create environments where we can ask questions. And a really important part of that is empathy and compassion.
Yeah, I always remind people in my classes, like, if you don't understand this, that's okay. That's why you're here.
Yeah.
Like they're supposed to understand everything. And I'm like, yeah, if this isn't making sense, like, ask questions.
Yeah. And another thing that I talk about a lot is, and again, this is obviously close to my heart because I teach, but that I want people to be able to work in environments where learning is celebrated rather than feared. And learning becomes something that people are scared of when they worry that they will be judged for not knowing stuff. Because if you think that there is something wrong with not knowing stuff, then you're not going to get excited about learning, because learning is by definition you not knowing stuff. Because if you have to learn something, that means you don't know it. But if you feel insecure about not knowing things and you feel like you're going to be judged for not knowing things, then you're not going to get excited about learning things. You're going to be worried about it because you're going to be worried that it exposes your ignorance. But working in IT means you cannot avoid needing to learn stuff. It never stops changing. The number of new tools and technologies is increasing exponentially all the time. So it's getting worse all the time, the amount of stuff that professionals have to learn. And the more insecure we feel about it, the more hideous our jobs are going to be. If we can get excited about learning, then we can embrace the thing that we cannot avoid, that we all have to learn stuff all the time.
Yeah, I'm definitely always trying to learn new things because, yeah, like you said, you just get left behind eventually because it seems like being a software developer today, there's a lot more to learn and know than there used to be.
Yeah.
I
Yeah, it's interesting though. Sorry, I interrupted you.
Well, I was just gonna say it's weird though because it's also with the advent of YouTube and Udemy and all these classes and there's tons of literature. It's easier to learn new things now, but just the amount of things that you have to learn, I feel like is much higher.
It's impossible. So one of the things that I try to help people with is to get over that feeling I'm going to get left behind. Because you're already left behind. We all are. We are all always going to be behind. There is no such thing as in front because there's too much of it. So you have to accept you are going to be behind because there's so much new stuff and you can't keep up with it. You just can't. So instead of feeling like you have to keep up, instead, what you have to think about is what do I need to know in order to do what I need to do? And then get excited about learning that. But if you think that what you're trying to do is keep up or not get left behind, you're fighting a losing battle. There's too much of it. You are behind. You're always going to be behind. So you have to accept there's always going to be things you don't know. And rather than focusing on what you don't know, just focus on what you need to know to do this and then try and get excited about learning that. Does that make sense?
Yeah, no, that makes a lot of sense. It's like the learn smarter, I guess, not learn more. Like just
Yeah, exactly.
like
Yeah.
yeah, figure out what technologies you need to do your job and maybe like a little bit of the adjacent ones. And if you're not doing web stuff, maybe ignore all the Kubernetes or whatever that people are always.
Exactly. You don't need to know that stuff. You
Yeah,
can't be an expert in everything.
I
It's
think
so
that,
it's just what do you need to know? Or what are you interested? I mean, because sometimes, like for instance, I talked about making iOS apps before. When I was building iOS apps, that wasn't for my job. It was just for fun because I have an iPhone and I
yeah,
thought it would be fun. So sometimes you're doing it just because it's fun, and that is a great reason to do something. So it doesn't have to be because you need to. But you have to be really careful about, for instance, feeling like you need to know what your neighbor's job is.
yeah,
Like if you work in a team where people have specialisms, you don't need to know how to do the thing that your colleague is doing. You need to know how to do the thing that you're doing and trust that they can be expert in something else. And if you need to ask them questions, then they'll give you the answers, but you don't have to know what they know.
yeah. I think it's also I find it important maybe, and maybe this is just me, but like having just a good general overview of just knowing like, okay, I don't know anything about Kubernetes, but I kind of understand it a very vague idea, like what it is. And I kind of know like, okay, if I start doing web stuff where I need a bunch of servers, then I'll go look at Kubernetes, right? And just kind of like having in the back of your mind just a handful of these technologies where you just know just enough to know like when that technology might apply. And or also too having a list of like experts. Like I know, for example, like in my world, like FPGAs, right? I don't know anything about writing FPGA code, but I know a guy who's an expert at it. So I have that in the back of my head that like if anybody asks me a question about that, I know where to send them.
It depends. So, if you are working in a context where Kubernetes is part of your stack, and for instance, if you have a team that's managing a Kubernetes cluster and the code that you're writing is being deployed to Kubernetes, then it will be useful for you to have an overview of what's going on there. You don't need to know the details, but it'd be useful for you to know what is Kubernetes? What does that mean? But if you're not, who cares? I mean, it can be really tempting to think, well, I need to know that stuff. But like, do you? Do you need to know that stuff? And you can drive yourself mad thinking that every time anybody says something you haven't heard of, you have to then go and look it up. it depends. Is it relevant to what you're doing? And also, who are you? What kind of person are you? Because some people really enjoy having that overview of all of the buzzwords that are currently being thrown around on whichever bit of the internet you happen to inhabit. Some people it can be a very efficient way of dealing with your workload to say, I don't need to know about that. I trust that other people know about that. It's not relevant to what I'm doing now, so I'm not going to let it clutter my brain. I'm going to be focused. I'm going to keep my brain clear for the things my brain needs to know. And this is where you have to be careful and recognize that people are different. Some people, if you say to them, you don't need to know what Kubernetes is, they'll be like, I can't bear it. I have to go and find out what it is. I'm sorry. Some people be like, oh, phew, thank you, because I really don't want to know what Kubernetes is. And people are different. So you have to acknowledge that different people are going to want to know different things, but you also have to give people permission to say, if it's not relevant to what you're doing, you don't need to know about it.
Yeah, no, I think that's a good philosophy. Yeah, keeping in mind that people are different too, I think is
Yeah.
important. Yeah, I am definitely naturally curious, so I kind of just want to know, like, I don't know, need to know a lot of detail, but just having a place to put it in my mind, I think
Mm-hmm.
helps. So,
Yeah.
yeah.
Yeah. And I make notes about everything constantly. So I've got like my own little markdown based database. And whenever I hear a new term that I don't understand, I make a little note and put it in my database. But then, the work that I do means that I have to have a much broader knowledge than if I was just working in one team building one product. So there are things that I need to know that other people don't need to know.
Well, that is too, like, yeah, as a consultant, like I run into that because like in the LabVIEW space, there's like two main frameworks that people use, right? And if you're working in a team, you just need to know whichever one you use.
Mm-hmm.
But as a consultant who floats between teams, I need to be aware of both. So I think that might
Yeah.
be part of where that mindset comes from too, of just
Yeah.
having enough that I can talk somewhat intelligently about anything. And like if somebody, and also too, like to the Kubernetes thing, I feel like that's just a term that comes up a lot that I see a lot in a lot of, and to me, like knowing what that means, that, oh, it's this web technology thing for like launching multiple servers. I can immediately, when I see that, I put that on I said, okay, that doesn't apply to me.
Mm-hmm.
And
Yeah.
it's very easy to do that. Whereas if I didn't know what it meant, I constantly, every time I say it, be like, wait, does this apply to me or not? And so
Yeah.
in my mind, I at least need to put it in a bucket of like, does it apply to me or not?
Yeah.
Yeah.
And if it's something that's coming up in conversations that you're involved in, then it's useful for you to know what it is. But if it isn't, then, you
Yeah,
know,
yeah.
and what's interesting at the moment, I mean, like this is just, we're just using this as an example, but actually at the moment, there's a lot of pushback against Kubernetes. There's a lot of
Yes,
people,
actually, I have
people are
noticed.
using it unnecessarily because it became, the latest shiny thing. Oh, we have to have Kubernetes in the same way that people are saying we have to have AI. Well, what for? Why? I mean, maybe you do, but you don't just want AI for the sake of it in the same way that you don't just want Kubernetes for the sake of it. You have to have a use case in which it's actually going to give you some value.
So that's something I struggle with is a new thing comes along and I don't have a use case for it, but sometimes you don't know how useful things are till you actually try to use them on something. Does that make sense? Like sometimes like something comes along, you're like, ah, it doesn't seem all that useful. And then you experiment with it and you're like, oh wait, everybody's using it to solve this problem, but it actually solves this other problem that I have really well. Do you ever run into that?
Yeah, but I it's a risky path to go down because it's not really scalable. If I were to say every new technology that comes along, I'm going to give it a go just
Yeah,
in case
yeah.
I need it. I mean, I don't think that's workable because there are too many of them. So I would rather have a concrete use case. I need to achieve this, and somebody says, "Well, have you tried using this?" Or I look it up
Yeah.
and I find a bunch of people saying, "Well, this technology is useful for this use case," but I can't learn all the things all the time just in case one day I might need them. I mean, that's a bit like the hoarder, keeping all the broken things in the cellar just in case one day it might be useful.
Yeah, I feel like I've gotten much better. I feel like when I first started out, I definitely had that like want to learn everything. And now I feel like I get a lot of more mileage out of the things I learned just because I try to pair them with a project that I'm working on.
Yeah, I mean, one of the things that I do, I've always done this, is if there is something I'm interested in knowing more about, then I try and find a reason to learn it. So
Yeah.
particularly when I was working in consultancies, I would try to get myself onto the projects that were using the things I was interested in learning about so that I could learn it in a concrete context. Could learn to use it meaningfully to actually solve a problem rather than learning it in an abstract context. But I quite often will find excuses to learn a new thing. But for me, and again, this is potentially a thing that's because not everybody learns in the same way. But I find that I learn a lot better if I have a reason to learn, like I've got a concrete purpose in mind. So if I can get myself into a context where it's meaningful and useful for me to learn a thing, because it's actually going to achieve a thing I need to achieve, then that makes it a lot easier for me to learn it.
Yeah, I feel like things are stickier that way also. And also if you
Mhm.
have like an application, then you tend to find other applications for it as opposed to like force fitting it.
Yeah.
Yeah,
Yeah.
very interesting. So I'd like to ask everybody who comes on the show a question, which is, can you tell me about an experiment that you tried that didn't turn out the way you thought it would, and what did you learn?
Yeah, so one of the examples that I thought of for this was when I've been working with a team and we have been learning how to do ensemble work, so mob programming, as some people call it. And typically, when I'm introducing ensemble work to a team, I'll have some quite rigid structures in place. When you get used to it and you get better at it, you can relax a bit and you can mold it to fit your own context. But to start with, I will have some quite rigid structures. And one of those is that people take turns and they take turns for a specific amount of time. So there'll be a timer that goes off and it's like, okay, end of your turn, start of the next person's turn. And there are lots of reasons for doing that. The obvious one is it means that everybody gets a turn. It means that nobody is just being a passive observer. Everybody is getting to have their hands on the keyboard and actually write some code. Um, and the question is often, how frequently should we change? And I was working with a team that were changing, I think it was every 6 minutes, which seemed like quite a long time to me. And it seemed like there was a long time before people were getting to have a turn. And so I suggested that we halve it, that we go to 3 minutes. And my idea was that my hypothesis was that it would mean that more people would get their hands on the code, that things would move more quickly, and that people would kind of feel invigorated by that. And it would kind of, mean that everybody was very engaged in what was happening because very quickly it would be their turn again. And I was wrong. So what actually happened was it made everybody really stressed out. Because in this particular team, people were actually used to taking their time a bit more and really thinking about things. And there were a couple of members on the team who just found that kind of frantic pace was just stressful. And what it meant was that they were always worried that their time was going to be up. So they felt like they were in a terrible rush, which made it harder for them to concentrate on what they were doing. And it also meant that they didn't look forward to when it was their turn. They worried about when it was their turn, which also made it harder for them to think because I thought, oh, God, it's going to be my turn soon and it's going to be really frantic and I'm going to have to move really fast and everybody's going to be watching me and I'm going to make typos. And one of the things that I encourage when I'm working with ensemble is that we have regular retros, particularly at the beginning, at the end of every session. And very quickly, I got the feedback that, please, can we stop doing this 3 minute? We don't like it. And so actually, we went back to 6 minutes and we found other ways of addressing the issues that I'd originally identified. But yeah, I think it's really important to be able to recognize sometimes you try something and it doesn't work.
Yeah. No, that's a good lesson. I have one last question, actually. So we talked about ensemble programming a bit. Do you have any tips and tricks on how to sell that into organizations? I encounter a lot of people who are very reluctant to try it.
Yes, it is hard. So there are there are lots of things that you can talk about. One of the things that I find is really helpful is to talk about experiments. And this is true of introducing anything new. You can say, okay, well, my hypothesis is that if you try this, you're going to get a more cohesive team who are more collaborative. You're going to get a much faster and better spread of knowledge. You're going to find that the knowledge about the domain spreads really quickly throughout the team, as well as knowledge about technologies. You're going to reduce the bust factor. So you're going to have far fewer individuals who only know about the one thing, and they hold things up because they're the only person who can do a particular thing, because everybody has to always go to them. So those are all the reasons why I think it's effective. I could be wrong. You tell me what your reasons are for thinking it won't be effective, and let's deliberately do an experiment. Let's just try it and see. You tell me what you think will go wrong as a result of us doing this. I tell you what I think will go right, and we try and find some way of measuring that, and then we try it. Let's prove it. Let's do an experiment. And it's actually a lot easier to sell experiments, particularly if you have really clear parameters of what your reasons are for thinking it will succeed, and also what anybody else's reasons are for thinking it will fail, and then try to measure that. So what you're doing is you're demonstrating in practice. You're saying, okay, you don't think it will work. I think it will. Let's try it. Let me prove it to you. And that's a really good way of doing things. But talking about spreading of knowledge is a really good way of helping to sell it. Talking about collaboration, talking about getting people working effectively together. And also, limiting it and saying, I'm not saying you have to do this all the time. I'm saying, let's just do it a little bit and try it and see. There is, I'll share a link with you afterwards. I have a talk about ensemble work that goes into all of the reasons why it's a good idea. And I'm pretty sure there's a video of that available somewhere, and I can share that with you.
Oh, yeah. Somehow I missed that, but I'll have to go watch it.
Well, that's me wondering now, is it available online? I'm sure it is. I think I literally shared this link with somebody the other day, so I'm pretty sure I can find that for you. Yes.
Okay. Very cool. All right. Well, thank you very much. It's been a great conversation.
Cool. It's been a pleasure.
Thank
you for inviting me on.
Yeah, and we'll have Taylor include in the show notes how people can get a hold of you if they want to. So,
cool. Brilliant. Thank you.
All right. Thank you.
That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram @TheLVExperiment.